All right, so let's continue with the Pythagorean theorem here. Um, we took off by taking the square root of 136, and that's how we got 11.6619, and we rounded to one decimal place. That 6 allowed us to make that other 6 a 7, so that's why we have 11.7. That's the distance. This is the distance between A and B. So it's 11.7 units. Okay, always take that square root. So, and I apologize on the graphs if it's just making sure that it's, you know, the graphs might be a little messed up. Okay, so I do apologize about that. Um, so we want to find the distance between points P and Q. Okay, so here's P and Q. We're going to do the horizontal distance first with the x's. 1, 2, 3, 4, 5, 6. So that's 6 units. And then 1, 2, 3, that's 3 units. So this is our vertical distance 3, which we'll call B. And this is our horizontal distance, which is A. And we want to find C because now we have ourselves a right triangle, okay, with our horizontal, a vertical distance and our horizontal distance. Okay, so we use the Pythagorean theorem, right? A squared plus B squared equals C squared. Okay, so that's 6 squared plus 3 squared equals C squared. 6 squared is 36 plus 3 squared is 9. This gives me C squared, which is 45. 45 equals C squared. We're not looking for C squared, we're looking for C. So what we have to do is we have to take the square root of 45, okay, in order to get rid of this power of 2 that's here. Okay, so we take the square root to both sides, and we get that C is approximately 6.708. Since we're rounding to one decimal place, right, we go 1, 2. This 0 tells that 7 to stay. So our total distance is going to be 6.7 units. Okay, that's how we do the Pythagorean theorem. Okay, we're going to do just a couple more examples with our distance. Right, we're looking for A, B, and C. So here's B, just in case you can't see it. Here's A, and here's C. Okay, so this is what can be a little bit rough. We want to find the distance between all 3 points. So the first distance is A and B. So we're looking for this distance right here. Okay, so we're going to find our horizontal distance and our vertical distance. So let's find our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's rough, right? We're gonna show you a trick tomorrow where it's a little bit easier. 1, 2. So now I know that this is my B, this is my A, and we want to find C. And C will be the distance here, right? So we take our 12 squared, sorry, 2 squared plus 12 squared equals this distance between A and B, which we'll call C squared. Okay, so that's 4 plus 144 equals C squared. 148 equals C squared. We take the square root and we round to one decimal place, right? So the square root of 148 is going to give me 12.2. We're rounding. So the distance between here is 12.2 units. Okay. And then we want to find the distance between A and C now. So now we're going to go the other way, right? So between these 2 points, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. To me, that's so annoying. So I'll show you the trick tomorrow. 1, 2, 3, 4, 5. Okay, so we got our B, we got our A. Let's do the Pythagorean theorem, right? And this is going to be here. So for this one, right, for B, 8, and I'll try and do some work down here. But for 8, we're going to do 9 squared plus 5 squared equals our distance C squared. Okay, so that's 81 plus 25 equals C squared. Okay, and that gives me a grand total of 86. Oh, sorry, that's wrong. 81 plus 25 is 106. And then we take the square root because that's C squared. And C is equal to, when we take the square root, is 10.3. And then you can do the last one. I'm going to leave it there because we've done a couple of practice problems. You can tell whichever distance is the shortest. Right now, we know that AB is longer than AC. So you're going to do it one more time to find that distance, okay? hopefully that helps. Let me know in the comments or